Okay, well, welcome everybody to this
Recording in progress.
7th MANRS Community Meeting. This is the second of two sessions today. So we had one earlier today with some great discussion between with Jeff Houston and the rest of the panel that you'll see today. So I just want to first of all mention that we are recording this. You should have seen that message up on your screens. But I would like you to introduce you to one of our MANRS co-chairs, and that's Andrew Gallo, who is working for George Washington University in the US, and he'll be running through the program today. So Andrew, over to you.
Thank you, Kevin, and welcome to the second iteration of the community meeting number 7. Welcome from Washington, DC, coincidentally, home of ISOC. So we're gonna, we have a pretty interesting agenda. We've got some measurements, talk on measurements, and a really good panel discussion. Can you move to the next slide, please, Kevin? We'll jump right in. All right, so we want to talk a little bit about the steering committee election process, announce the vendors program, which went live last month, and talk about the growth in MANRS participation. Then we'll move to the presentation from Joao and have a panel discussion, and then get an update on the MANRS Observatory from Andrei. Next slide, please. So as some of you may be aware, the inaugural advisory group is transitioning to the steering committee next month. We are holding an election for 7 committee members in the first 3 days in November. Nominations are currently open, so please, if you know somebody who would be good for this role, or including yourself, please nominate. Anyone is eligible to serve on the steering committee. Prospective candidates can be from MANRS participants. You can nominate yourself, and if you know somebody who would be good for the community but is not currently working for a MANRS participant or associated with a MANRS participant, please nominate them, and that can be done by a MANRS participant. Voting information will be sent shortly, and there's a link talking about the nomination process. Next slide, please. So some very exciting news. We've launched a vendors program. You see the inaugural members of Arista, Juniper, Nokia, Cisco, and Huawei. On the next slide, we'll discuss what the program entails. So there are a number of actions and sub-actions that the vendors have committed to. Primarily, it's about supporting the network operators, IXPs, and CDNs in their MANRS mission and obligation. So action 1 talks about whether or not the platform from the vendors can support filtering, anti-spoofing, filtering for IXPs, and layer 2 protection at IXPs. There's also a component for promoting the MANRS program by discussing the MANRS program in training, setting up lab environments, providing technical resources, and having hands-on resources. Ongoing activities including advice, development, contribution, and promotion of the program. So thank you to all the members of that working group, and congratulations to the inaugural members. So MANRS by the numbers, you'll see a really encouraging growth in the number of participants. We've got 600 ISPs encompassing 757 autonomous systems, 95 inter-exchange points, 18 cloud and CDN providers, and the 5 vendors we just mentioned. Really significant uptick, so this is encouraging. So next we will go to a very interesting discussion. This one is going to be presented by Joao, who is a senior researcher at APNIC, where he spends most of his time measuring various aspects of the internet. Other activities include organizing ESNOG, the Spanish NOG, and chairing the RIPE DNS working group. as well as being a trusted community representative for ICANN's root key signing process. Joao.
Thank you. Can I share my screen now? I guess. Can you already see my screen or not? Maybe. Why do you rehearse these so many times and then when the time comes, there's always one more thing? Okay, how about now?
Yes.
All right, excellent. So this is a talk focusing on one aspect of routing security, which is the RPKI and some measurements we've been doing together. The full title is that. To be honest, it makes my site jump around from being so big. So I've moved to the next slide. Yeah. What this is about is measuring RPKI, and in particular, measuring the use people make of RPKI in terms of route origin validation filtering, the intended usage of RPKI. So when we were looking at this, we started by asking some questions. It's like, when you talk about routing security, what are you talking about? What's the objective? And you quickly come up with a long list of questions. And it's not clear to anyone, I think, because you will get a different answer from anyone you ask to, which of those options it is that you have in mind when you talk about routing security. Is it accidents, all forms of accidents, all forms of attacks, some forms of attacks, routing incidents, preventing from malfeasant or erratic usage of the routing system? What is it really that you are trying to do? In our case, in all discussions, I think everyone has mostly agreed that things should be taken one step at a time and not be overly ambitious, because otherwise you typically don't get anywhere if you try to bite more than you can chew. So one of the aspects that has gotten further is the whole RPKI usage and route origin validation that is enabled by the definition of RPKI. And what this intends to do is to prevent unauthorized routes to be used on the internet, so that users' traffic doesn't go to places they were not wanting to go. Which is the last of those questions in the list I presented earlier. So in our case, in our study, our intent was to measure the impact of invalid route filtering on users. Basically, if if we were to present a user with an IP address that is covered by a ROA, and at some time it has a valid or invalid ROA, depending on what phase of the experiment we are doing, what would the user experience? Would the user still see the content behind that address that perhaps they shouldn't, because the ROA says it's not a validated route, or don't they? And are they being protected? And of course, in the experiment, the content is innocuous. It's just a 1x1 white pixel. But it could be something else if it was someone else doing the presentation. So in the RPKI, you have two aspects to it. One is the production, and one is the consumption of the resources that you generate to put the system together. So in production, you see the generation of the ROAs. And in the consumption, you see who takes those ROAs and matches them against the routes that they get from their peers, and thus acts in consequence with the validity or invalidity of those ROAs. So populating the ROAs, generating them, is something that is going fairly well. Of the about 1 million IPv4 routes that you see on the internet today, we see ROAs counting up steadily to a number that's 84,000. So it's between 25 and 30% of all the prefixes that are out there, which is fairly good. for such a recent technology. In terms of routes, because ROA doesn't necessarily map one, the numbers are similar. 275 to 180,000 routes are covered by existing ROAs, existing published ROAs. So that's fair. The line is also growing steadily upwards and to the right. So that's nice. It's the internet way. In terms of addresses covered, the values currently stand at 30%. So that's a good indication that the ROAs that are being generated are not by the little guys or by the big guys. It's a healthy mix that represents the general ISP population. So that's also good. In the case of IPv6, the percentage is a little bit higher than IPv4, even though the absolute numbers are lower because that's the norm for IPv6. But in terms of percentage, it's bigger. So that's good. And the same applies to when you look at it in terms of percentage of routes. We are above 45% in this case, reaching 50 almost. In terms of worldwide distribution of who is generating those ROAs, it's an interesting picture because it's not a technology that seems to be in high adoption in terms of generating the ROAs by what you think of as the mature internet markets. It's more a different collection. And I don't have a clear idea of why this might be so. Maybe there is better advocacy in particular regions. Maybe there is a huge number of participants in other regions. And so even though you get to a few, you don't get to the majority of them. It's anyone's guess. I'm not going to venture any suggestions here. So after you produced and published these ROAs, there's the question of who you actually makes any good use of them to filter, to puts them to good use, basically. There is an intermediate step to this process, which is you need to have a local copy of the ROAs of everyone else before you start applying the validity filters. So what you typically do is create a local cache. You go around the internet fetching all the declared publication points following from the different trust anchors, and you collect all the information. And what we see, because we publish our own ROAs, and so therefore all these people who maintain local validation caches have to come fetch us and update the data as we publish it, is that there is an increasing number. It's not overwhelming, it's small. As you can see, there's about 3,000 different entities. Even you can see how the different protocols are being used, and there are certainly step functions in there as adoption of new versions of the RRDP or rsync come up and go away. RRDP seems to be the choice of now, and that's good. That's the way it should be. We also have some numbers on periodicity of updates, which would make up for interesting talk by itself. But let's go on. Of the people who, of the ISPs that validate based on the ROAs, we transformed these into how many of the internet users are behind those ISPs. So how many people out there navigating on the internet are protected via their ISP from going to bad places in terms of having invalid ROAs. And then you have a little bit of a different picture than what we had in terms of the ROAs being generated. The numbers seem to be stable and slightly decreasing recently, at around 15% of the users. So that's compared to the success of generating the ROAs, these figures are a little bit of a disappointment, because the whole purpose of generating all those ROAs is that they get used to protect the users, right? We started this measurement more than a year ago, and it has been fairly stable. We do this through a CDN that has many points of presence throughout the internet. So it's fairly extended, and it allows us to present the ROA fairly close to the end user to see if it's the ISP that's offering the protection when that's the case, or the transit, because there are places out there in the world where basically the local ISPs all converge on one transit provider to get out of the region towards the rest of the internet. And if it's the case that it is the transit provider that is providing this filtering, then the ISP is shielded, and that's good until the day they get a second transit. And then because it's not them that doing the filtering, they get suddenly exposed, their users get exposed. And it doesn't seem that transit networks are doing much of this, although they are certainly, as we'll see in some maps later, doing it for some regions of the world. So this is a time series of 4 pictures that depict route order validation filtering throughout the last few months, starting with July 2020. Green means more, red means less. So typical culprit suspects, as you see, the Nordic countries tend to adopt these sort of security measures early on, and then some other countries. As I say, in the continent of Africa, it's particularly clear that some of these protections, green adoption, is not because of local actions, but because of narrow avenues to get outside that are themselves applying filtering downwards. In October, the picture changed a bit. The most notable change, as you can see, is the green coming up in Australia. That's due to Telstra enabling filtering there. And June of this year, and currently. It's a bit disappointing, to be honest, to see that there's a slight shift towards the red after there was a notable fraction of green. So this could be basically due to lack of interest or rollbacks in deployment. But since I'm a positive guy, I think it might also represent that there is an increase in network access diversity in upstream transit providers. And therefore, people who were protected by only having one transit provider was doing filtering. Now, as they get more access, which is good, provides resilience to the network, they seem to disappear from this picture. So it's not necessarily all bad, although green would be good. This is a picture of our measurements when our Telstra turned on route over origin validation a few months ago. And it matched what we see, basically matches exactly the dates that Telstra was mentioning when we asked them after seeing this. And their network isn't in the news, so supposedly everything is working well. So there doesn't seem to be an extraordinary amount of risk in actually enabling this and living with it. But like all security measures, there's always a little bit of hesitancy on turning them on. This is not entirely dissimilar to the deployment of DNSSEC, as we have seen throughout the years, where signing zones is something that people will readily do, will embrace. But when it comes to having validation turned on and at the resolvers, at the ISP resolvers, you see much less adoption. Because when you turn on validation, when you turn on filtering, is when the actual possibility of you getting things wrong might happen. And so people do tend to take a deep breath before enabling it. There are some places where there is a really good big contrast between the publication and validation. And we will illustrate this with the case of Mongolia, where mostly all of the IPv4 address space that is originated in that country is covered by ROAS. As you say, that's high 90%. So I think it's around 99%, in fact. So basically everything. But when it comes to using those published prefix ROAS to enable validation, you only see a difference being effective on around 25% of the population of internet users, of ISPs in the country. And that's because some of the big ones do, but the largest one doesn't seem to do it in a significant manner. When you see values around 5% for an ISP, that's quite big. What it probably indicates is that it is some customers behind that ISP, not the ISP itself, that is doing the validation. So where should we be doing this? Where should the filtering be taking place? Should it be taking place at the start or the transit? And we already saw cases for both, right? It's nice when your transit does it, because particularly in cases where you only have that one transit, when the transit does it, you are automatically protected without needing to do any work yourself. Problem is when the time comes that you get a second transit, and that second transit is not performing the same filtering, you then become unprotected, because as soon as there is the one path available for the prefix to allow your traffic to escape, you can count on it escaping, basically. The fact that one ISP, one upstream provider provides you with the barrier, with the filter, doesn't do you any good if any of your other peers provides an alternate path, because that's actually the purpose of a routing protocol, is to enable reachability. So it will do that. And another point of view, another way of looking at this is whether the filtering should take place on ingress. That is, should you be protecting yourself using route order validation from what everyone else is publishing out there? Or should it be on egress? Should you be a good citizen and implement filtering that prevents you exporting things that are not supposed to be there? Basically, routes that are bogus. Should you do this at level of prefix? Should you do this at level of AS? Good question. And are there any mechanisms that would be worth exploring? And I think there will be a talk later in this session about ASPA, so I'll leave that topic to be covered in that later talk. And there is the big question, of course, is what good does it to protect the origin if you don't have a protection for the path? And that's a big debate in the whole routing security arena, which so far doesn't have a complete answer. So you get lots of questions, and you have to think a little bit for yourself. What is it that you yourself are trying to provide to your users or to your customers? When you're running a network, be it an enterprise network, an ISP of any size or geographical spread, right? So that's a bit of an overview of the current state of adoption of the technology and who is making use of it and how it's protecting people, what amount of people are being protected by these mechanisms so far. It's a start, it's a young technology, and there is already, depending on the metric, a relevant level of success or a good start. And that's where I'll leave it for now.
Thank you, Joao. Do we have any questions? I see one in the window from Steve Wallace.
Let me see if I can stop. Well, maybe I won't stop sharing.
Do networks that drop invalids keep exceptions?
We don't measure that because our way of measuring is with specific prefixes that we control. So we have to assume, we are assuming, in fact, that our prefix is treated the same as all others. But there have been cases where things like what were used to be called golden routes were had exceptions hard coded into configurations. So it's possible. No one certainly wants to lose the route to Google or something like that. But we don't have any way of measuring that.
Got a comment from Tony. The move from 35% coverage in December 2020 down to 15% makes sense to me. Seems not to make sense to me. Sorry about that.
Okay. It is a bit disappointing. It doesn't necessarily mean that anyone who is doing it doesn't do it anymore. Although there may be cases like that. If anyone, as happens with a lot of security mechanisms, if you have a problem, your first reaction is to turn it off and look at it at a later time. Unfortunately, that's very human. But there is also the option that I was mentioning in my talk, that there were people being covered by their upstreams. And when they got additional upstreams, they suddenly opened escape routes or leaks for their routing prefix propagation. So perhaps no one stopped, but the fact that the network configuration changed now allows new paths that allow users who were being blocked from accessing this mal content to now be able to access it. And
okay. Randy wants to know, he congratulates you on the good presentation and wants to know if you're going to publish it with the artifacts.
With the artifacts, like when there are spikes because of things that went wrong with the measurement on that particular day? And no, I mean, things happen, they happen the way they happen. We are not perfect.
Sorry, Joao.
Okay.
What I meant was the fashion today in publication, academic publication, is your data and the code are made available for reproducibility, and that's referred to as artifacts.
Oh, all right. Okay. Sorry, I thought. Okay, so the code, I don't think you want to look at it. It will probably cause you permanent brain damage. But the data is actually, the web pages where we publish these pictures are all coming from web pages, have XML tables on them and are easily downloadable. It's already there, basically.
Okay, thank you again, Joe. Very interesting data and presentation. Next, we're going to move to the panel discussion, and Andrei will be moderating that. If you have any questions during the panel discussion, please put them in the chat. Andrei?
Yeah, thank you, Andrew. And Joao, maybe you can stop sharing your screen.
Yes.
So we can move to the panel. And thank you very much for setting the context for the panel. And also posting some of the questions. And I hope we'll circle back to some of those questions after the initial presentations. And in the panel, we are going to discuss more than just route origin validation, but other facets, other sort of, building blocks of the toolkit, because we all know that routing security is a complex matter and there is no one solution. There are many things that need to be done. So we have a great lineup of panelists, and Joao is being joined by Alexander Azimov, who is working for Yandex, and he is enthusiastic contributor to the IETF. He is an author of RFC and some of the internet drafts. And Mark Stucchi, my colleague from the Internet Society, who is a technical advisor for the European region, focusing on community networks, MANRS, and IXPs. Please welcome Joao, Alexander, and Max to the panel. And well, without further ado, we have two presentations, and then we'll have a discussion, moderated discussion, and we'll open the floor for questions from the audience. So if you have questions during the presentations or discussions, please post them in the chat and we'll collect them and hopefully address them in the Q&A. We'll start with a presentation on ASPA or ASPA. We really need to agree on how we pronounce acronyms and how we write them, because I couldn't figure out how to write BGPsec, which letters are capital and which are small. I think that's important for consistency. So let me give the floor to Alexander Azimov with his presentation about ASPA. Thank you.
Thank you, Andrei. I believe pronunciation is not the biggest issue. Still not the biggest one. Maybe one day it will be the biggest one, but let's hope it will be one day with the biggest one. So I'm Alexander Azimov, and at Yandex, I'm focusing on network monitoring, routing security, and transport architecture. And today I'm going to take you to the tour with the new RPKI object that is called Autonomous System Provider Authorization. Sorry, it's not the first slide. It should be the second one, but never mind. The biggest reason that we need another RPKI object is, of course, route leaks that are a violation of a peering policy. Our measurements show that route leaks may result in up to 50% of packet loss. At the moment, we have only unstable solution with ISET filtering that degrades with time and doesn't work at all if we're trying to check routes that are coming from providers. One may also be anxious about malicious man-in-the-middle attacks with BGP. The good thing that both issues can be addressed with ASPA. So ASPA, as I have already told you, stands for Autonomous System Provider Authorization. And here RPKI object that has next structure. Customer signs a set of its providers. And because in different address families, it may have different connectivity, we also have a field for address family. So it should be clear. And here we have already great difference from ISETs, because in ISETs, provider is responsible for adding its customer or a set of its customer to its own set. And normally everybody gets its customers, nobody delete them. And so that's why in ISET, with time, we are getting more and more rubbish. ASPA is different. Customer now is responsible for maintaining its peering policy and its representation in ASPA. It signs only its providers, and it can remove or add a new or old provider whenever he wants to do it. So the first building block of ASPA verification procedure is pair verification. One may find it very similar for route origin validation. So we're getting the list of valid ASPA records, create a list of candidate providers, and if the list is empty, the outcome of this procedure is unknown. If there is an overlap between the autonomous system that we are trying to check, if it's a valid provider, then it's valid. If the overlap is empty, the outcome is invalid. I hope it's simple. So during the next slides, I'm going to provide step-by-step description on how verification procedure is applied. And there would be some wonderful drawings. But to make life easier, let's stick on this slide for a few seconds. So if you see a circle on top of another circle, it means that the circle on the top is the provider of the circle at the bottom. If you see circles on the same level, that means that they are literal peers. And arrows, very important. They show direction of the check, not the direction of route advertisements. For the direction of route advertisement, we have indexes. So it should be simple. Let's try. First of all, how ISPA can be used to detect route leaks coming from customers. For routes that are received from customers, there is a wonderful node. We have, of course, ISPath that is part of BGP attributes. And ISPath of these routes may consist only customer to provider pairs. Customer to provider, customer to provider, that's all. If there is something else, it's a route leak. So on the left side, we have an example of a valid route. 1, 2 is valid. 2, 3 is valid. And the whole route is valid. On the right side, we have a route leak where autonomous system number 3 is leaking prefixes learned from autonomous system number 2 to autonomous system number 4. And we can easily detect it with ASPA because autonomous system number 2 haven't authorized number 3 to propagate its routes to upper layer, to its own providers. And that's why 2, 3 is invalid, and we are able to detect a route leak. The next part, what is about routes that are received from peers? And there is no difference. If we are receiving routes that are from peers, they are following just same procedure that routes that are received from customers. They may consist only of customer to provider pairs. So it's just the same. On the left side, we have a valid route. On the right side, same scenario. Autonomous system 3 is leaking. 2, 3 returns invalid, and so we know now that it is a route leak. And now the harder part, providers. With ASPA, you have a chance to detect route leaks that are coming from providers. It's a very important feature, but it's a bit more complicated because for routes that are learned from providers may consist of both upstream segment and downstream segment. So let's get into the detail on the left side. We have valid pairs 1, 2, 2, 3, 3, 4. And after that, we have invalid pair 4, 5. But now it's not about route leak. It marks the end of the upstream segment. But upstream segment must be followed by the downstream segment. And so the downstream part can be also verified with ASPA, but in the reverse order. So we, after we're getting invalid 4, 5, we're checking 6, 5, valid, good. 7, 6, valid, good. So on the left side, we have a valid route. On the right side, we have a route leak. And it starts the same way as on the left side. So we have valid pairs 1, 2, 2, 3, 3, 4, 4, 5 invalid, which marks the end of upstream segment. We're changing the order, and so checking 6, 5 valid, valid. 7, 6 valid. No, then it's a route leak. So it should go down, but for some reason it goes up, and so we're able to detect a route leak coming from a provider. So ASPA, its use cases start with detection of route leaks. If it is combined with ROAS, it's also capable to detect malicious activity in routing ecosystem. And the great thing about ASPA, while we don't have any objects at the moment, it already works. So the first to make a ASPA-like process was an NTT team, which promoted what was called a peering lock. It was using some well-known default-free networks plus some well-known peering relations to build regular expressions and check routes that are coming from customers and peers. Unfortunately, with regular expressions, you can't expand it to check the routes coming from providers, which makes it less useful for networks that are not tier ones, but networks, for example, like content providers like Yandex. So that's why we also started using ASPA-like algos, but a slightly different manner. We applied it to the data feed that we are receiving from the BMP. And it gives us a way to detect route leaks that are happen for some remote autonomous system numbers, but also it gives us a way to detect route leaks that happen to our own address space, which is crucial. Let me show how. So here will be another scenario. And let's start from a good part. So if there is no leaks, it's good. So we have, of course, we of course, I'm sorry, I'm not native speaker. It happens from time to time. So, but if the route leak happens, it's still not a problem. Because if, for example, autonomous system 5 is leaking prefixes, it doesn't really matter if autonomous system 2 is filtering it out. So while route leaks are not propagated, it's still good leaks. But if these leaked prefixes are accepted and further propagated, of course, it becomes a problem. And the moment leaked prefixes becomes best path for some autonomous systems, we want to detect it and to detect it fast. And here is another interesting note. If autonomous system 2 will use leaked route learned from autonomous system 5, it will send back this route to autonomous system 1. Why? Because it is just a new best path. It's sharing its best path with the originator. Yes, there is autonomous system 1 in the path, but autonomous system 2 doesn't care. And that's where BMP take place. Because with BMP, we are able to retrieve this data before any loop detection or any other kinds of filtering are applied. And on these BMP data apply ASPA algorithms. And it works. It's a production route leak monitoring system that is used at Yandex. And on this slide, you can see an example of a real route leak, where one of our peers leaked a prefix learned from Yandex network to its upstream provider. And this upstream provider sent it back to our network. And we were able to detect it, contact the megaphone and ask them to check their routing policy, and everything got fine. So one may wonder how many ASPA records is needed to make this real. And the number is not that high. It's only 18 ASPA records that is needed to get monitoring, or in other words, filtering, really useful. And in these 18 records were included only well-known default-free networks, or T1s, fewer ASPA records that are used for autonomous systems of Yandex, and a couple of important for our network tier 2. So I hope you have already realized that ASPA is working, and it can bring benefit for even the earliest adopters. It doesn't change the BGP protocol itself. So you don't need to wait until your neighbor will update its software and support new capability or whatever it is. It's out of band and very easily for deployment. It works in some parts of the global network. It works at Yandex as a very good monitoring tool. But how to make it working in your network? First, if you are interested in these technology, I will call it technology, please start working with your vendors. Start telling them that you want these on one of your future software updates. Start talking to your favorite RIR and ask that they should need to support another RPKI object. And there is still work that must be done on the IETF documents. It's not that crucial, but it's important to make the text easily understandable for the implementers. And by the way, if you are running some open source projects, the implementation of SPA is also very welcome. So please read the documents, give us feedback. Feel free to contact me using my email, or you are free to contact any other author of these documents. So that's all for today. If anybody have any questions.
Thank you, Alexander. We'll defer the questions till the Q&A session. Thank you for this presentation. And hopefully the internet draft will progress in the ITF quickly. And I understand there is a running code already. If you have a GitHub repository that people can try and play, just post this in the chat. I would like to give word to our next presenter with another building block from the toolkit, to Max Stucchi with IS cones. Max, the floor is yours.
Thank you, Andrei. Let me start sharing my screen so you can see the presentation. I'm Max, and I work at the Internet Society, but this is something that I've been working on even before I joined we started before I joined ISOC 2 years ago. And it's about looking at something that's similar to ASPA, but from the other side. So here what we do is look at generating feature parity between the Internet Routing Registry and RPKI. And the goal when we started was to create something in RPKI that would match what we have as AS sets in the IRR. The idea was to make everything easier, provisioning easier, and then to have this go independent from the routing registry, because in the IRR, if you want to chase an AS set, you have to look into different databases, and you never know which one is the correct one. So thanks to the facilities built by RPKI, we came up with the idea of AS cones, which give us the granularity of declarations. We have a default namespace. We have just one, supposedly one big repository, and a simple validation process. We'll see this because in the course of working on the drafts, we came up with some solutions to try to help validation, but also we started with the idea that stub networks, so the networks at the edge of the internet, shouldn't do anything. Although we'll see in a moment that there is a little tiny thing that they might be doing, and that's due to the security model that we tried to build in the last version of the draft around AS cones. So in AS cones, we have the idea is to have two main objects, two main type of objects, the policy. When I mentioned granularity, I meant that you could decide, I have a customer cone, I have a series of customers, they have their own customers and so on, and I want to announce one specific cone with these specific entries to one upstream, and then I can declare I want to announce a different set of customers, a different cone to another one of my upstreams. So you can differentiate. And the idea is that you have this policy that says, I have announced this specific AS cone to this upstream of mine. And then we have the AS cone object that defines either ASNs or other AS cones. So this is the definition of who my customer is, who my customers are, and if they are just a stub ASN or an AS cone. So this is relatively simple. The AS cone has a unique name, but it has to be unique just inside the domain of the single ASN, and then we preface it with the ASN that we're talking about. Now, looking instead at how we find the policies, how do we use, what's the idea of using AS cones? basically it's similar as building prefix lists. Is if you've ever looked at how BGPQ3 or BGPQ4 work, I take the AS cone I want to look at. I expand all the AS cones inside it. If there is a recursion, I remove that. And then, well, recursion, yes, if there is if my AS cone is also reflected there, if the same AS cone is included more than once, I just remove that. I get the list of all the ASNs referenced by all the AS cones in there. And then I pick the ROAs where that ASN is listed as the originator. And I do it for all the ASNs in my AS cone expanded. This is the starting point. And then how we built a security model. One of the first feedback we got when we started working on AS cones was, let's not replicate what's in AS sets. It was mentioned this morning. I don't think I caught it this afternoon. But the problem with AS sets is that you get entries that are added. So I am on a transit network. I add the new customer to my AS set, but then when the customer decides to not renew the contract, sometimes these operators forget to update that. And so we have plenty of garbage in AS sets, and we tried to find a way to not have that. So when I want to add an AS cone to another AS cone, the holder of the AS cone I want to add has to acknowledge and say, I'm fine with it. Why? Because in some cases, we have small ISPs who don't understand in AS sets how actually that works. And they sometimes add big transit ISPs to their AS set, creating issues in the long run. So we wanted to avoid this. And then if I add instead an ASN to an AS cone, the acknowledgement is optional. So the holder of the autonomous system number can go into what's supposed to be a web interface or something and click and say, I'm okay. I acknowledge that I'm a customer of that ISP, of that ASN, or they can avoid doing that. But given this, we can build different layers of building these prefix filters. So we could have a loose system where we get anything that's in an AS cone. We can get an opportunistic type of filtering where I get any ASN and any AS cones. And then for the ASNs, I just consider the ones that have validated, the ones that have acknowledged. This way, I try to force the holders of these ASNs to tell me, I want to be there. And then almost strict, where we just remove from our prefix list any subtrees where any one single entry is not validated. So I have a portion of my customer cone that I just removed because something didn't validate there. Or I can do very strict filtering and just consider an AS cone if everything in there has been validated. Every holder of any resource in there have acknowledged. So this is a way to add a layer of security to AS cones. And then we also have a procedure we have come up with for the removal of an entry. As the holder of an AS cone or an AS or just an ASN, I can go in and request the removal from another AS cone, and that's forced if and it's managed by the central repository. So in this way, I can, when I want to leave as a customer a certain ISP or provider, I can just do that on my own. This I actually wanted to skip, but there could be an integration with ASPA. And this is basically it. I know we are a bit late on time, so I promised Andrei to stay in my 10 minutes, and here we are. You can find the material on GitHub. There is the draft, and discussion is welcome on the Grow ITF working group. And then if you have any questions, You can use this email address, or I can provide also my ISOC email address later on. So thank you very much.
Thank you, Max. So this is another example of technology in the making. It's great. So we looked at different tools in this toolkit, and I'd like to move to the discussion part of our panel and ask panelists a question. So yeah, routing security and routing system is complex. No one solution is applicable. Maybe more of them need to be done to secure routing system. So from your perspective, what should be the priority? What should be we focusing more as a community and also as individual network operators? I think, Joao, that was one of your questions. You alluded to something. Maybe let's start with you. What do you think?
Okay. Well, previous security add-ons to internet technologies have shown that the ones that enjoy a better level of success are the ones that you can deploy without being dependent on others, and the ones that can be deployed incrementally. So anything that you can do that has those two properties, go for it immediately. Maybe it doesn't cover every aspect, nothing will, but those are things that you would be independent to deploy and can go ahead, right? In terms of what population is being addressed, we think that protecting the users is the whole point of this exercise. The routing system is there to basically take the users to their intended destination. So the protection of the path is what one would preferably want. From all the questions that were in that list at the beginning, that's the ones we would do. ASPA, as Alexander mentioned, has the property, one of those good properties that you can go ahead by yourself. So that's definitely one thing. Publishing growers, it's easy. It enables others to do filtering, even if you decide not to at this time, right? And then finally, if you're doing RPKI and learning about it, eventually I would hope you do the filtering yourself as well. It's hard to figure out how there could be a mechanism or a protocol or something that would protect every combination and every path. But we do what we can, and by doing, new ideas come up. So I think, like with anything internet, doing it is always the first step and the one you should take.
Thank you, Joao. Alexander, what's your take on this?
Mostly I will just support what was just said. And I think that every operator, every not only ISP, but also content providers or even stub networks should do their part. And it's good to start with simple solutions and moving toward maybe more complicated, but more full solutions without gaps in routing security. So signing rows is easy. I don't understand anybody who haven't done it yet. Making original validation on your side is also important because you are protecting your egress traffic. It might be you might want to make it step by step. First, for example, apply it on your peers. Next, on your IP transit, and so on. Check it, try it, verify it. Because, for example, in our networks, we faced a critical issue with one of our vendors while we were testing it. It's not there, but also I suggest, for example, check the software updates. And there might be some important notes. And finally, there is a place when we want to be sure that the base path is valid. Valid in terms of peering policy and valid in terms of routing security. And my thinking is that ASP is can really fill the gap and give us a chance that we will live in a much more secure world compared to what we have now.
Thank you. And Max, what how can you respond to that question?
Well, as I did this morning, as I said this morning, I second what Joao said, what Alexander said, but I want to add, I have a hope, because I realized it during the day, I have a hope that soon we'll see a larger number of networks doing validation, because I think one of the obstacle for the small networks we see across the world is that they implement a platform. They use a platform. They use MikroTik, which doesn't support ROV as of now. But hopefully, in a few months, we'll have a stable version for the new for the RouterOS version 7, which should bring a lot of networks in line with what is available nowadays with RPKI and do route object validation. ROV. So it's a hope I have, because, as we said, BGP-SEC is not going to happen. Then we'll have ASPA, and then hopefully one day also ASCONES. I think ASPA is more important than ASCONES, so that should go first. And then hopefully we get a more secure internet.
This is great news indeed, and hopefully MikroTik can join the MANRS equipment vendor program at some time to sort of shoulder that effort as well. So Joao, in your presentation, you sort of posed the question: transit versus edge or stub networks. Let me expand a little bit and maybe put you on the spot again. So they're different entities, right? In the routing system, they play different roles. Not only network operator, IXPs, there are other types of networks. From your perspective, what is sort of which types of networks can make more impact, where we should maybe focusing and pushing more?
Well, I would say it depends on where you are. If you are in a part of the world where your internet access is channeled through a few small entities, upstream providers, then the fact that these people upstream do or do not filter will have a huge impact on everyone underneath, right? With the caveat that I mentioned in the presentation, that you have to be careful, because as you grow as a network and you seek additional peerings, you have to be aware that you might lose some of your protection if you're not doing it yourself. If you outsource your protection to someone else, you could be in for a nasty surprise. So in that sense, cool that you can benefit if someone else does it for you, but be aware. Since the routing system is about taking user traffic to somewhere else, to whatever the destination is that the users want to go to, protecting that path is what should be done. And so ideally, the most reliable protection will come from stub networks, because those are the ones that have a direct connection to you. But it's also probably one of the complicated ones because of the scale and the risk that they perceive they may encounter, right? And there's also the matter of, local access stub networks usually live in competitive markets, and they have to be careful what they do, because the last thing they want to do is to lose customers, right? So they have to balance this. So transits, on the other hand, have the potential to have big impact, but they also have the most diverse set of customers, and it's also a handful to manage those different scenarios that they provide service to. So what else? Filtering, for instance, at the content development, content delivery networks is worthwhile, but it doesn't really protect the user, because if the packets are getting to the content delivery network and through paths that shouldn't be there, or from origins that are not the right ones, ultimately the content delivery network doesn't really care. If it's an attack, they will protect it the same way they're already doing. But the user with the legitimate origin probably doesn't even know that there is anything going on, right? unless they lose access. And the content delivery network is too far away from the user to be of any effect, I think, to the user, which is ultimately what we want to protect. So I don't think there is a unique answer. Everyone has to do their bit, and everyone has a different set of requirements and constraints and risks. Making people aware, making network operators aware of the pros and cons in their particular scenario, I think is the best we can do right now.
Thank you. Yeah, and indeed, in MANRS, we have 4 different programs sort of targeted at different entities and expecting different contribution. And speaking of CDNs, one of the idea of the program when we start is to leverage their peering power, because people want to peer with CDNs and cloud providers, to encourage sort of better routing hygiene from their peers and other members. Before I move to the next question, I would like to remind our audience that please, if you have questions to the panelists, please post them in the chat. We'll collect them and have a free sort of discussion after I pose the last question to our panelists, and that would be, when do you think we can consider our job done? Let me start in different order and start with Max Stucchi. Max?
And similarly to this morning, I get the most complicated question and be the first one to try to answer. It is really complicated because we can, as I said, as I already said, it's a complicated matter because it implies, as Joao was saying a moment ago, there are so many different actors. We can try to add ASPA, we can try to add ASCONs, we can add, we could try to put in the mix also BGP-SEC, which maybe one day might happen. And although this morning we decided that we should have all a t-shirt for the next meetings that says BGP-SEC, no, never happening. And this was showed by, described by Geoff Houston. We can add all these layers, hope that as many operators as we can will join MANRS, will start using these features, but then there's always that tiny bit of variable, the misconfigurations or errors that we can't control too much. So we could do these and hope that also we'll come up with more ideas to implement, maybe in RPKI, maybe in configurations, maybe someone will come up with a wonderful new BGP extension that will help us all. And then we will consider it done only when we will see no hijacks, no route leaks happening on the internet. But my question is, will this ever happen? Will we ever see something like this? So I'm not sure, but we can try.
Yeah, no one has a crystal ball, but I think, yeah, that's a great sort of answer. Joao, Alexander, do you have a sort of a different perspective or something to add?
First of all, I'd like to highlight that I can't fully agree with Joao about CDNs because I believe that, okay, we the internet was designed as in a kind of flat topology. We all have Atom system numbers, they are equal, but of course we have different traffic volumes. And I believe that if the biggest network, according to traffic volume, will secure what they are learning and what they are propagating, the things will be changing in a better way. And speaking for measuring the success is that I have already mentioned that route leak itself is not a problem. The problem is when it becomes propagated and so it gets the traffic. And for example, if it gets traffic from Yandex, it's not a good thing because, as I was telling my presentation, it may bring 50% packet loss, and not all TCP sessions will survive through such a black hole. And if we one day will have a network secure enough to make route leaks or hijacks, it doesn't really matter, stop affecting the connectivity between users and services, it will be great. And from the side of content delivery from my company, we are doing a lot of things to secure our network from leaks that are happening around us. And so the biggest and the most important thing is the happiness of the users. So they want their services. We're trying to provide them, but so the same attitude to their users should happen also from the end networks that are providing the internet, and so securing the internet and will be the joint success or joint failure.
Right. Okay. Joao, do you have anything to respond?
No. I mean, I agree with Alexander as well. Each network has to see things from their own perspective, right? And for the CDN, protecting itself from spurious sources is important. The user might not be aware of it, but for the CDN, it might be important. So everyone has a slightly different perspective. Yes, I agree.
Okay, well, thank you. And let's see if we have any questions from the audience. I see one question from Jean-Michel asking, regarding ASPA, any support from equipment vendors? I don't know who can answer that question. Alexander, are you aware of any implementations?
I'm aware of a couple of prototypes, but I'm not aware of, because we still don't have real ASP objects. You cannot expect that there will be software updates from vendors that will bring this technology to you. But you may expect that the different parts of the technology, because we need verification procedure at the router, we need RTR protocol, we need RPKI validator, we need a signer. So all parts of this puzzle are coming. And for example, if you ask your vendor for plans, it may result that we will have compatibility tests earlier than later, and less bugs will be in these kind of implementations.
Right. Okay, and if we have vendors on this call, especially MANRS equipment vendors, raise your hand if you are prototyping ASPA, working in this direction. I see another question. Can you describe how ASPA works for peers using a route server when the route server doesn't appear in the ASP path?
Okay, I was just typing the answer for this question. It's a very good question, and in general, the first idea that we had that for prefixes that are learned through the IX, we can just apply the procedure same as the procedure that is applied for the providers. But it also limits the opportunity of route leak detection, especially if the route server is not present in the path. So the current version of the document suggests to use the absence or presence of the route server autonomous system in the path as a token. If it is present, we're applying downstream verification procedure. So likewise, the procedure that is the same as for providers. If it is not present, we are applying upstream verification procedure. So we are working just like we are working with peers and customers.
Okay, thank you. And ASPA is very popular. So Alexander, the next question is also for you. How far, Rich is asking, how far away are we from getting the RFCs for ASPA approved? And how long do you think until it will start to be rolled out?
As I was telling you, the BGP security or routing security will be a joint success or joint failure. So the documents are cooking. The main algos are verified and tested, and we have prototypes, but still there are some corner cases in the text that need to be addressed. So I encourage you to read the documents and give us feedback. The more feedback you give us, the faster the document will proceed.
Indeed.
Unfortunately, the authoring document is a very big obligation. So, and as any other ITF contributor, we have to maintain balance between what we are doing for ITF and what we are doing for our day job. And the more contributors for the documents we have, the faster we are proceeding.
Right. And I see a hand from Jacob. Jacob, would you like to say something about your plans?
Yeah, so I'm from Cisco. We do have a prototype of the ASPA. It's not released, but we've been using it internally. Now, because we don't have the RTR protocol, of course, so we just configure the ASPA records on the box itself. Actually, I think that's quite a workable solution to just configure them. So whatever you know of your customers, you just configure it yourself. I also happen to believe that anything that requires the customer to do something is not going to work, right? The ISP looks after the customer, and that's it. The ISP has to do whatever it needs to do to look after its customers. If you do anything that requires a customer to do something, it's just too hard. Customers will not do stuff. Customers will not put their records up. They will not sign their prefixes. So whatever solution is, it has to come from the ISP. And yeah, so in our prototype, we can have the ISP configure the ASPA records.
Thank you, Jacob,
yeah,
for this
it's not
good
released,
news. Yeah, and your pragmatic view, I think, on sort of deployability of technologies. And with this, I'm conscious of time. I'd like to thank our panelists very much for this interesting panel, and move on. Andrew, the floor is yours.
Thank you. Really good discussion. So the next up is a review of the MANRS Observatory data. So it's back to you, Andrei.
Yeah, we have this football here. Thank you, Andrew. Let me just share my screen. So I would like to talk not about Observatory per se, because you probably, many of you are aware of this tool that we released a couple of years ago. But there's some of the aspects of the observatory that I'd like to draw attention to. When the tool was developed and released, the main objective was to inform you as MANRS participants about your degree of commitment. And that is really necessary, we felt, all of us, I think, to improve reputation and transparency of the effort, and also to facilitate continuous improvement and correction. Also including peer pressure, we can discuss sort of, how our co-fellow networks are doing as far as MANRS is concerned. So if you log in the MANRS Observatory, you can see these donut charts at the bottom of the landing page, which actually tell about this MANRS readiness scores. And we have well, depending on your filters, you can see the MANRS readiness scores for the globe or for your particular network. There was a measurement framework developed, and we query data, public data, and calculate metrics that constitute MANRS readiness scores for different actions. And some of the data is more reliable, and some of the data is less reliable, and less reliable in the sense that it's very difficult to, without knowing the real intent, to figure out if a routing change is an attack, misconfiguration, or is it just a legitimate BGP change? So, for instance, as far as filtering is concerned, we observe pretty high rate of false positives, also false negatives, but that's over less concerns as far as conformance is concerned. So specifically about that part, we were thinking, how can we improve that measurement? And one of the things that we did is we added another data source next to bgpstream.com, where we started. We got in contact with the team at Qrator and integrated their BGP Observatory, which is now, I think, called GRIP, their data in the MANRS Observatory. And that's something that we released this summer. And while releasing this, we also introduced another feature, and that is a feedback loop. So the idea was that another way of reducing these false positives is to get real feedback from the operators, so they can validate if this incident is indeed an incident or is just a wrong assumption from the data collection system. So we can tune the filters and therefore reduce the false positives. Why do we need to do that? So if you look at this report table in the observatory, and this is only available to participants, so general public doesn't have access to this yet, but all MANRS participants can see this table. So that's why I know that not only MANRS participants are on this call, so I've blurred some of the names to protect the innocent or not so innocent. But you see the numbers here. And if you go to the web page of MANRS, you see these check marks. I think there's a discrepancy, and we discussed this for some time already, that we would like to replace those tick marks with actual numbers that will demonstrate how well or how bad the network, particular network, is doing as far as MANRS is concerned. But to do this, we need to improve the quality. We need to be confident that the data that we are showing up is accurate, that it's not false positives, and we're not ending in endless discussions of, oh, that was not an incident. And to reduce these false positives, we are asking you to provide feedback. So the feature that is already in the MANRS Observatory is this feedback loop. When you log in and you go to your detailed report, you see those icons that allow you to provide feedback on specific incidents. And you can have this dialogue, and you can indicate whether it's an incident or it's some data is incorrect, or is it just a legitimate change. And this data will allow us to work with the developers, with the teams at maybe BGP Stream and most probably at Qrator to improve their filters and tune down the amount of false positives. So by doing this, we hope that we can finally, maybe first on opt-in basis, move from these tick marks or checkboxes to real percentages. And that will further improve transparency and credibility of MANRS, because not everyone knows that when a network is applying for MANRS participation, there is an audit process that we check MANRS conformance and check how well the actions are implemented. But I think when we publish these numbers, it will make much more visible and obvious that this is the case. And also that will help sort of improve the public and peer pressure on networks that are not doing that well to facilitate continuous improvement and correction. So I will follow up on the mailing list with more details. I would like to know your opinion about how you feel about that, and hopefully you can commit to provide these feedbacks. But also if you agree for the observatory to generate reminders, for instance, that you can easily go back to once a month and look at the incidents that are listed in the observatory and rate them whether they're incidents or not. And that's it. Thank you very much. We really count on your support.
Thank you, Andrei. That wraps up our program. Are there any additional questions or comments? I see a couple of things coming through the chat. From Rich, he's suggesting that the observatory should send out monthly emails. So thank you for that comment. And Alexander has some additional information on ASPA or ASPA. And I like Andrei's comment that maybe when we come up with acronyms, we should specify if the expectation is to pronounce or to spell them out. Consistency in our documentation. So this wraps up number 2 of community meeting number 7. Thank you for joining and participating. If you have any further discussion, please keep it going on the mailing list, especially around nominations and elections, which we mentioned before. Nominations are open and elections are November 1st to November 3rd.
Andrew, just one question. I heard there might be a quiz that we set up for the participants to answer. Maybe I'm confused, so I'm just looking at my colleagues to see if that's indeed the case.
If we have time, I'm here for that. Just give me a couple of seconds. Just feel free to close it, and then I can do the quiz.
I think that's it.
Oh,
So,
okay. So give me just a couple of seconds.
Sure.